comes around.
Hey guys, welcome back from lunch. I know more people are going to be filtering here over the next few minutes, but it's time to get the afternoon started. We had a fantastic morning. Just, by show of hands, how many people have been around the project from, say, day one or even the first year? So a couple, yeah, out there. So if you guys remember, Open Compute, day one had a project, or shortly after, the founding sort of networking project we had was called Virtual I/O. Virtual I/O ended up being a little bit ambiguous, and so we had, as a community, we came together and said, hey, we really got to solve this networking component. It's sort of the last bastion of like the appliance model in the data center. You've seen some press out there from big networking vendors talking about how OCP might be a threat to their business, and they're going to be less reactive and more proactive about that. So we think that that's actually really cool and really good. We want to get in there and compete with the best of them. So my next speaker is going to come out, Peter Krey. He's the president of Krey & Associates. His title called Curb Your Innovation 2, which is a clever title. He's got a really fun talk for you guys. Please help me welcome Peter Krey.
Good afternoon. Good afternoon. Thanks, everybody. Welcome to the event. I'm going to apologize in advance for my presentation this afternoon. I got to try to cover a lot of slides in 20 minutes. So if you find me staring down, looking at my speaking notes, my condolences, but we're trying to cover a lot of good stuff. So today's session is going to be in four key sections. The first one is like, who and what is Peter Krey? The second, first part of the networking contents is we're going to go back in time. I'm going to reuse some of my Open Networking Summit material from 2011 and 2012 regarding cloud computing and what it meant inside a financial services enterprise, and then how it connects the dots with networking. Part two is Back to the Future. Hope there's TV fans out there that knows what I'm talking about. And it's going to be reusing, Back to the Future is going to be the Open Switch Today update, including where it started, all the key contributions, progress to date. And then last in part three is the road ahead, what we expect to be happening. So, okay, here we go. So who and what is Peter Krey? Peter's an independent consultant about 11 years, previously 25 years of core enterprise infrastructure engineering and application infrastructure inside financial services, all the way up to a CTO role and head of architecture reporting into CIOs and folks above. A majority of my clients are enterprise CIOs and CTOs and their hands-on teams. On occasion, venture capital and private investors, serial entrepreneurs, and every once in a while, advisory roles to cool startups. Constantly, I'm on the hunt for emerging disruptors and innovation to save. The concept and influence to me of open absolutely rocks. I'm a huge fan and participant in things like Open Compute. I focus exclusively on thought leaders and enabling disruptors. Startup founding teams, only CTOs, only heads of engineering, developers, and hands-on engineers. In a nutshell, only those that actually create and make things. I strive to remain a hands-on technologist. I've been part of enterprise teams that have built and delivered some of the largest x86 and Linux-based high-performance compute grids in financial services, Hadoop big data proof of concepts, open source enterprise cloud projects, and now open networking. Today, my goal is to provide East Coast enterprise context, so here we go. So part one, back in time, how did we get here? All right. So the following slides are a subset of my 2011-2012 Open Networking Summit. The sarcastic title was Curb Your Innovation. The presentations are on the first two ONS events in 11 and 12. Objective of this session is to provide some East Coast context to my colleagues out here on the West Coast and also people doing hyperscale. The key goal for the following is to summarize enterprise learning regarding key infrastructure elements missing from my enterprise CTO colleagues. Hint. This definitely results in huge networking focus. Okay, so now we're traveling back in time, back to 2011. Imagine sitting inside of Stanford University for the first Open Networking Summit. So we're going to begin from the vantage point of asking colleagues, exactly what the heck is cloud computing? If you ask 10 of my enterprise colleagues, you'll get at least 15 different responses. That's supposed to be a joke. Okay. For external cloud, you'll hear Amazon, Rackspace, Google, Azure, and others For internal cloud, you'll hear about 99% VMware. Again, this is back in 11. vBlock and/or Acela, hope you guys remember. The enterprise-based virtual machine farms, AKA almost cloud. And regarding open source cloud, back in those days, you'll start to hearing about this new thing called OpenStack. Overall, my apologies. Overall, very unclear signal-to-noise ratio regarding the cloud from enterprise commercial side of things. It reminds me of a very old Saturday Night Live joke. I'm going to give you a hint of how old I am. Shimmer. It's a floor wax and a dessert topping, similar to the Taste Great Less Filling commercials from Miller Lite. So to me, only one of these 6 cloud models is actually correct. So per my 25 years of enterprise experience, the following slide is the most succinct definition of cloud I've seen to date. The real answer is cloud is not traditional enterprise IT. From the upper hand right, enterprise thinking around cloud can really be the blind leading the blind. Whether it's internal or external, first time ever, enterprise customers and developers have had choice, freedom, and control. No IT people, no process, no bureaucracy, no business case, no governance, standards compliance, architecture reviews, 9 to 12-month delays, and so on. Cloud is a dislocation of excess process and delay, and potentially massive acceleration via 100% automation. With true 100% automated cloud, you get what you need in minutes, not months. Radically change what enterprise customers expect is possible, how much it could cost, how many minutes versus months. So what does this have to do with networking? Tons. Per my visibility into both East Coast enterprise colleagues and the hyperscale West Coast, for engineering and operations, these above photos resonate and characterize things to me. On the left, you have enterprise East Coast approach, which feels very, very manual, time-consuming, overly complex, low technology, antiquated, inconsistent, I'm almost done, error-prone, very difficult to repeat in terms of speed and scale. It also reminds me of a sarcastic wisecrack co-authored with a global CTO friend. I wish he was here, but a couple of you will remember this. Enterprise IT puts the no in innovation. And if during the same session I would say, Peter, what does the right photo remind you of? I'd say West Coast hyperscale. In sharp contrast, the West Coast feels highly automated, highly repeatable and consistent, and highly receptive to adopting and advancing innovation. Lots of open source, standards-based, vendor-agnostic hardware, and tons of automation. Out east, tens to hundreds of infrastructure devices are manageable per an admin. But out here, thousands to 10,000s are administered per admin. Again, wisecrack. What does this have to do with networking? Tons. Good news is I'm not the only one to observe these issues. A group of enterprise CIOs back in 2011, they were on the cover of Information Week. They've already publicly agreed traditional IT is too darn slow. Open and direct CIO quotes made the cover, and they were direct quotes. Again, none of these quotes are me. These are all enterprise IT CIOs. There's 3 up here that got publicly quoted. There's dozens that can't do this. And cloud computing is all about 100% automation, open developer tools and software, self-service, and 0% bureaucracy, process, and delay. Once again, what does this have to do with networking? Tons. These above bullet points are summary and synthesis of all the sources below. It's a good mix of geek and business source information, including the publication The Economist. Per these sources, the most popular and effective clouds are 100% self-service, 100% automated, vendor-agnostic, open, and IT process-free. Again, 0 process and bureaucracy. Either a command line script or a few GUI clicks away, and we're free and independent to get whatever we need. Again, this is minutes, not months. And in a dollars per unit comparison, 2 use cases are compute and storage, they're 1 to 2 orders magnitude less expensive. Now, how the heck is this thing possible? Again, networking is a very, very big key. All right, one more here. Via text-based summary, this is setting up the role for the AHA slide coming up. These categories, infrastructure as a service, platform as a service, storage as a service, they organize in summary all the reference sources shown along the bottom and not from a vendor marketing deck or an executive briefing. The NIST source is very frequently referenced, and I'm also included a non-traditional and business-oriented sources in this above summary. The point here, my focus today, is at and below infrastructure as a service. Everything else that's possible needs to sit on top. If you don't get the infrastructure right, everything else above is severely impacted and in jeopardy. Overall, lots of cloud thinking in terms of an OSI stock model. But a graphical cloud model of these luckily reveals a very seriously missing key item. Despite the text-only diagram before about all infrastructure as a service and all the other as layers, what jumps out to me is networking is clearly missing, and it has been missing for quite a long time. In a nutshell, our overall automation layer can only go as fast as the slowest part. How the heck can anyone enable 100% automation and 100% self-service, not enterprise IT, those user requirements without including and enabling automation at the network layer? And without enabling language-independent automation interfaces such as REST APIs, how the heck can anything be automated in developer mode? Vendor neutral, open source, and in a standards-based way. So in summary, what the heck about the darn network? To my eye, this is a giant, enormous gaping hole, also nicknamed as the Grand Canyon. From an automation standards-based vendor-independent perspective, my nickname for networking today is the new Grand Canyon. No matter how you look at current thinking and closed proprietary technologies in enterprise networking, getting across this giant gap is just about impossible. And in order to produce cloud automation, it requires automated CLI and developer API access to at least 3 components. So from my prior client experience on the super hypervisor layer, Xen Server and KVM, fully open APIs, no problem. On the storage side, things like OpenStack Swift, Ceph, MongoDB, others, no problem via REST and other direct multi-language APIs. Networking, non-trivial problem. It's very closed, very proprietary, very, very limited open developer API access. In a nutshell, the state-of-the-art developer's key is copy-paste. And what about open innovation developer tool access that shine in automating the hypervisor and the open storage automation? This next slide was something, again, I summarized for the Stanford presentation several years ago. The key point here is that we can only go as fast as the slowest part. For enterprise technologists, why the heck can't we use developer tools that enable cloud hypervisor and storage automation? The left-hand box is from 2011. The right-hand box is a subset of what's now available in 2014. Coincidental that there's more appropriate and open developer tools today in 14? No way. For my enterprise Linux high-performance compute grids, big data, enterprise cloud, and other open source enabled projects, it slammed me that we have 0 open source developer tools for networking, 0 open APIs, and back in 2011, unlike today, extremely limited Linux distros on the switches. Sarcastic question. Why are almost all of these open source developer tools readily accessible and usable on my $35 Raspberry Pis, and none of them are on a $35,000 Tier 1 switch? Another way to look at this is talk to COOs, CFOs, people that are responsible for multi-billion-dollar budgets in big organizations. From a non-technical OpEx and CapEx perspective, there's also huge potential impact here. It's very difficult to get senior enterprise colleagues to disclose networking OpEx and CapEx percentages of their total cost structures. And not much in public domain information from places like Gartner, Forrester, and others. So let's take a shot at this. Let's make some conservative assumptions. It's not hard to imagine that some of these enterprises consume 20 to 30% of total CapEx and OpEx from networking. In fact, in many organizations, it's very, very predictable to be one of the top 5 line items. And over half, it's in the top 2 to 3. The bottom right list gives some very interesting ranges for potential OpEx and CapEx savings. Clearly, not nickel and dime. So this is not just about OpEx and CapEx save. Automation is also all about orders of magnitude reduction in time to deliver and orders of magnitude increase in consistency and quality of the configuration, quality of operations, etc. All right. Back to the future. So we're coming back. Good news, we're no longer stuck back in 2011 and 2012. We're back to the future here in 2014 here at the Open Compute Summit. Enterprise cloud automation, software development, tinkering, and prototyping has provided huge key experience for me. And it's also fueled the need to be very focused on enterprise automation and Linux-based open source software development. Luckily, there are some awesome Open Compute, Open Switch accomplishments to communicate today, so here we go. So back in May 2013, we got very, very lucky. On May 8th, Frank Frankowski announced the Open Compute expansion and inclusion of the Open Switch while at Interop. Frank's blog post describes, and I quote, "A new project within Open Compute will focus on developing a specification and a reference box for an open, OS-agnostic, top-of-rack switch. Najam Ahmad, who runs network engineering team at Facebook, has volunteered to run the project. It's our hope that an open, disaggregated switch will enable a faster pace of innovation in development and networking hardware, help software-defined networking continue to evolve and flourish, and ultimately provide consumers of these technologies with the freedom they need to build infrastructures that are flexible, scalable, and efficient across the entire stack." Sorry to be reading so fast. I've got to cover these slides fast. These 3 web pages are just a small sample of the tons of web media, and I want to say thank you to Mr. Frank for actually opening the door for us. So what happened next? Just a few weeks later, on May 16th in 2003, Open Compute Foundation held the first engineering workshop at MIT's campus in Cambridge, Massachusetts. The first photo is Frank doing the event's welcome and opening remarks at the Wong Auditorium. And the other 2 photos are the first Open Switch technical working sessions at MIT's Status Center. This was hosted by Crawford of Open Compute and Najam of Facebook. I snuck off to the side and took pictures. So part 1 of the workshop was led by Cole and Najam for attendees to initially contribute and distribute their ideas via an Etherpad session. So it was really cool. We had this big room of about 90 or 100 folks, and the contributions were real time. It was really, really cool. Part 2 is a separation of attendees into 2 independent working groups led by Najam and myself to further develop and identify their contributions. Both independent groups were rejoined, and the whiteboard photo was a result of Cole, Najam, and myself categorizing and capturing non-proprietary, 100% open source project ideas, feedback of potential open switch projects for content and coverage. In a nutshell, it was an absolutely awesome session. I also want to say many thanks to Ken Zollet at MIT. He helped us get access to Stata and snuck us in. And I also want to say thank you to Kurt Brunet, for creating and demoing the initial ONIE bare metal provisioning release at this session. So then, starting in late June, Najam, John Hoover, and Doofus Krey, it's the little tiny photo, we kicked off the creation of the Open Switch charter document. By late July 2013, the initial Switch doc, the charter doc, was ready for the Open Compute Incubation Committee. In a nutshell, key contents included the May 16th MIT-based engineering workshop, all the Etherpad contents, and whiteboard contributed contents. It was not Najam and John and I distorting it. It was us summarizing it and categorizing it and communicating it. So everyone that was there, they produced and contributed key contents. The initial version was Switch-based hardware focused, and the project will be expanding in the future. It will be expanding its scope to include a broad range of Open Switch software, including open Linux distros, developer APIs, and tool sets, and more going forward. Okay, back in November, we also got very, very lucky. On the 8th, Frank Frankowski announced the expansion and inclusion of Open Switch while at Interop. Frank's blog described the new project within Open Compute would focus on developing specification and references for Open OS top-of-rack switch. It's our hope that an open disaggregated switch would enable. I apologize, I think I got the wrong talking points on this slide. Anyway, in 13, let me back up. On 13, Frank had a blog post updating what had been accomplished by Mellanox, Broadcom, Intel, and also the Cumulus guys by donating ONIE. My apologies for the wrong talking points there. Back at MIT. Thanks to Kurt Bruin and his crew at Cumulus for the ONIE bare metal provisioning code, it not only exists, but today can also be accessed on GitHub. ONIE is a common multi-hardware switch provisioning software as a project. ONIE enables large-scale automation and OS installation on tons of switches. Version 1.0 supports the legacy PowerPC switch control processors, and an upcoming ONIE version currently in development will also be supporting the x86 switch control processors. Good observation yesterday, that x86 version was demoed at our working session, and it can be accessed on GitHub. 2 URLs are up there. Again, many thanks to Kurt and the crew at Cumulus for all their open source project contributions. The next big accomplishment we have at the Switch project is contribution of the very first open switch hardware spec from Broadcom called Open 1.0. The first open switch specification was donated by them. It's on the Open Compute website, over 48 pages of specification content. It's a really good document. They're targeting 10 gig top of rack. Some people call it leaf, and they're also targeting 40 gig core, others call it spine. Based on Broadcom's Strata XGX Trident 2 switch chip and the AMD GX series low power x86 control and application processor. This thing features a broad range of potential 10 gig and 40 gig pluggable I/O modules. This enables a wide range of switch port configurations in a 1U chassis. It's designed and optimized around cost and power savings while enabling open source software development at the same time. Broadcom software layer and SDK are also being ported onto multiple x86 Linux distros. And by the way, Kurt Bruni demoed yesterday the x86 alpha release for ONIE, and it's actually working pretty impressive. Looking forward, it also sounds like Interface Masters is working on a low-cost software developers open switch as a version for the x86-based Linux distros and developer tools. And Broadcom is expanding and increasing enterprise key functionality on their Open Compute-based open switch systems, so stay tuned. Second accomplishment is Mellanox just also donated a 44-page switch spec. It's their MSX1400-OCP. It's a Switch X2 x86-based top of rack spec. The switch is 1U, 48 ports of 10 gig E, and 12 QSFP uplink ports of 40 gig for non-blocking throughput between rack and aggregation layers. This switch features a latency of 250 nanoseconds, some very impressive power efficiency, all while providing optimal performance for open rack and enterprise data centers, targeting financial services, Web 2.0, high-performance computing, cloud applications, and similar things. This switch also proposed to utilize a series of Intel x86-based control and application processor. The reason I mention that is that enables some pretty robust, pretty highly functional Linux distros for developers. Yesterday at the Open Switch Engineering Workshop, Mellanox presented their current SDK. Very, very important for OCP participants to be enabling open source switch development. Last accomplishment is also by Intel. Thank you. The third one is their 1040 Ethernet rack-mounted switch standard spec, version 1.0. Its proposed open network platform switch reference design contribution, and the above are potential design images that are in the spec. From what I've seen, it's a 48-port SFP plus on the 10 gig ports, and 4 QSFP 40 gig ports, again, all in a 1U switch. This is also including proposed subsystems for the switching, x86 control processor, internal interfaces, some pretty efficient power cooling, and also a standard 19-inch rack enclosure. This is based on Intel's FM6764 Ethernet silicon switch, supporting enhanced features across a whole spectrum of great stuff. So please stay tuned for future contributions and collaborations from the folks at Intel. All right. So we're done with Back to the Future, and we're back to today. So last but not least, for myself and Najam and John Hoover, what's the road ahead? Well, so far, upcoming open switch spec documents are going under continual review and more approval, so work in progress, stay in tune. Please feel free to provide feedback. Second question is, will there be additional open switch spec contributions? So it's question mark, it's on the radar. We're keeping our eyes open. And again, the two target configurations that we're hearing about from people are edge/leaf, and others the core spine. Third, what are open switch software collaborations? Well, so far we're seeing Linux OS level stuff that's very much work in progress. Been some phenomenal announcements, awesome stuff from the guys at Cumulus. Looks like the genie's out of the bottle. And then the same thing with Linux tools at the application level. Developer APIs, tool sets, automation, source code control. That whole two-page box thing I had about 2011 and 2014, all these open source developer tools that are on little cheap $35 open boxes, they're coming. Next three categories are kind of looking at the things in the future. What might there be for optical interfaces? Are there going to be contributions for 100 gig and more? What kind of monitoring are we going to get from server-based silicon photonics? Is that even a viable discussion point? And last but not least, enabling beginning of mainstream, cross-discipline, fully open networking hardware and software. Closing thought. To me, my old school enterprise colleagues back east, Open Compute is the analog to the Khan Academy. It provides fantastic, completely open information from which all of us can not only learn, but also contribute. So I want to say thank you to everyone and look forward to collaborating going ahead. Pop quiz from the movies. Does anybody recognize Castaway? Tom Hanks was stuck on an island, but he got back. Shawshank Redemption. He climbed out. And last but not least, the old one from Steve McQueen from The Great Escape. So, closing thoughts. Thank you very much.
Thank you, sir. All right, guys. So this is a testament to the power of Open Compute. You know, the sort of the last bastion of the appliance model completely opened up through the community. This was a community-led effort. We didn't approach, the board of directors didn't approach any vendor specifically and say, hey, let's go do this. This was the community saying we need to solve this. So moving right along, and by the way, guys, around 2:30 today, we're going to bring all of the project leads up, and they're going to talk about sort of the plenaries about how their sessions have been going. You see, you know, the room's a little dispersed. We've got tons of people down in the actual project rooms working technically on the projects that make this community happen. So come back, listen to the plenary, listen to the project leads and what they've been talking about, because this is going to set the pace for the next 6 months, the next year of what we're going to go work on.